Hi, everyone. Just wanted to take a minute to talk about a problem such as this one, where we are solving essentially a bunch of smaller distance equals rate times times problems, um, but they're all combined together into one particular equation. So I just wanted to go over an example similar to this one. I know we did a similar to one to this one in class, and a similar. You've done a number that are similar in your homework, but I want to make sure you can reference this and come back to it if you have any more questions. So let's read through it. We're saying a bee flies at a rate of flies at 10 feet per second. And remember, when you ever see anything like this, feet per second, miles per hour, that's a rate. So as I said, we're dealing with a situation where we're going to have distance equals rate times time. And we are given a rate. So remember that. We are given a rate directly to a flower bed from its hive. The bee stays at the flower bed for 15 minutes, so we're given a time, and then flies directly back to the hive at 8 feet per second, another rate. It is away from their hive for a total of 20 minutes, and so we have a final time. So essentially what we're asking for here is we're saying what is the equation I can use to find the distance of the flower bed from the hive. So we're saying if we're solving from distance, right, we have a rate times a time. However, at the end, we're given a time, right? So if we're given a time, this is a little preview into what we're going to do later on in this section, in this chapter. But essentially, if you were to divide by the rate, you would get time is equal to the distance divided by the rate. And that is ultimately the crucial component to this problem. Because again, we're solving for a time at the end. So we need something to be a time plus a time plus a time is equal to a time. So at the end, we are given that it took 20 minutes. Okay, the only problem is here we're dealing with feet per second, and here we're dealing with minutes. So I don't want to write that as 20 minutes. At the end, it did take 20 minutes. However, I want to write that as seconds. So we have to do 20 times 60. And 20 times 60 is ultimately 1200. You could have done that in your head. It's a little, I've done a number of these videos today, so my brain's a little tired. So that's why I just use the calculator. All right. So we have now, again, a distance. I don't know what the distance is. That's what we're trying to find. So distance over the rate, because that's what I did over here, over the rate, and that's 10. Plus 15 minutes, so 15 times 60 is ultimately going to be 900. Plus now we're doing with an 8 feet per second. Again, I still don't know what the distance is going to be, but we know it's this over 8. Right, so this is going to be our equation. Basically, we're saying the time it took to get to the flower, plus how long it stayed at the flower, plus the time it took to get back was equal to this amount of time. Now, if you were actually going to be plugging it in, you would plug in this particular equation because it's telling you not to simplify. So you would actually plug this in right here, and that would be your answer. Now, if we were actually solving this is a different story. So I'm just going to, before I do anything with the fractions, I'm going to just isolate everything with the d on the left-hand side. So let me just subtract that. So I'm going to end up with d over 10 plus d over 8 equals 300. Now, let's think to ourselves, what is the smallest, the least common denominator? Well, think about it, factors of 8, 8, 16, 24, 32, 40. 40 is also, when you're dealing with 10 here. So we essentially can rewrite this. If we multiply all of this by 40, times 40. We're going to clear the denominators here. So that would be 4d plus 5d is ultimately equal to 12,000. So then we get 9d is equal to 12,000. And then finally, divided by the 9. Oop, 9, not d. Divided by 9. Divided by 9. And then if you were to check that, you would ultimately get that the distance. Did it tell me to round? Didn't tell me to round. Okay, so anyway, it would ultimately end up being, if we were to put that in a fraction, well, we just leave it as that. But you could also simplify, divide the 4,000 over 3, and we're dealing with a unit of feet. And if we were actually rounding, that's approximately 13.3 feet, or you do the 3 repeating. All right, so that is how you're ultimately going to solve this problem. But the real thing to remember here is distance equals rate times time. So that means time is equal to the distance divided by the rate, and similarly, the rate is equal to the distance divided by the time. So that is the crucial component to this problem, and I hope that seeing this out helps. Have a great day.